Good morning all viewers and welcome to WeLearning, an online educational platform. Now for today I will be giving you a quick intro about a description of acid, base and salt, but before that let us get into learning more about Vista's WeLearning platform. For all the new viewers out there, those of you who are new to this platform, let me give you a quick intro on what is Vista's WeLearning all about. Our motive here at Vistas is to provide a quality education for all. This is a live session that is occurring, so if I'm visible to you and if I'm audible to you, please give me a thumbs up. So I'll have a quick look at my cell phone, so people give me thumbs up if I'm visible as well as audible. All right, so I have received a thumbs up from Popo. All right, excellent, excellent Popo. Good morning to you. Right, so like I was saying that at Vistas WeLearning, we try to provide a quality education to all the students. So let us look into the services that we provide here. Now the services that we provide here at Vistas is WeLearning, which is the online platform that you're into. So what we do here is provide a quality education for all the students, no matter what the background they come from, could be rich or the poor. So it's a free lessons and classes that are provided to all the students. In case of VSMS, is a software, an online software, a smart tool that helps students progress in their academics. And lastly, we have VTalk, which is a future service that we'll be providing. It's a one-to-one discussion between a teacher and a student. All right, so let's dive into our session for today. So today's will be a reaction with acids and bases. This will be a session 2 of the chapter acid, bases and salts. So let's do a quick recap of the previous session about the intro of acid, bases and salt. Now, the couple of things that we discussed in the previous session, and those are how to test a given acid and a base. So, two forms of test that we conducted. One is change in color and the other is by olfactory indicators. So, what was the change in color that we observed is due to the litmus paper. So, litmus paper, which is made from a fungi called lichen. So, this litmus paper, when dipped into an acid or into a base, you notice a change in color. So how does the color change for a given litmus paper when dipped in acid or a base? Let's look into it. So first, if when a litmus paper, particular color of a litmus paper, red. So let's take a red litmus paper and dip it into acid. Okay? And then take the same litmus paper red and try to dip it into base. So what color change do you observe in case of acid and a base? So a red litmus paper, when dipped into acid, you do not notice any color change, isn't it? In case of a red litmus paper that is dipped into base, you notice a color change occurring, that is, it turns into blue. Yes? All right. So similarly, when you take a blue litmus paper, all right, take a blue litmus paper and then you dip it into an acid, and after that you dip it into a base. What color change do you observe when a litmus paper of blue in color is dipped into acid and then into a base? Very good. So when a blue litmus paper is dipped into a base, you don't notice a color change. But whereas a blue litmus paper, when dipped into an acid, you see a change in color where it changes to red. So this is a visual method. This is a visual method of determining a given substance being an acid or a base. And there were few examples that we noticed, an acid and a base. Yes, very good. Now, also an olfactory indicator. There was one particular olfactory indicator how to determine an acid and a base. And the olfactory indicators are onion, vanilla, and so if you can give me the third one, I'll give you 5 points. So go ahead, comment on the third olfactory indicator. The third olfactory indicator, for those you reply, you get 5 points. All right, waiting. Okay, so there are more viewers who are joining slow, but anyways, let me present you the answer. So the third olfactory indicator is garlic, all right? The third olfactory indicator is garlic. Yes? All right. So there are two ways you can determine a given substance is acid or a base. One is by color test and the other is by an olfactory indicators. Okay. Now, presenting to the slide where we discuss today's session, which is reaction with acids and bases. Let us look into the first type of reaction. First, the learning objective. What are the things that we're going to discuss today? So today will be the discussion based on reaction of metals with acids and bases, particular metals. Reaction of metal carbonates and hydrogen carbonates with acids, metal carbonates and hydrogen carbonates, all right. So we will be looking into the reaction of metal carbonates and hydrogen carbonates with acids and bases, and a final type of reaction which is called a neutralization reaction. Are you ready? Shall we dive into the first type, which is the reaction of metals with acids and bases? You ready? All right. So first, what are the commonly used acids in lab? So what are the common acids that we use in laboratory? One is hydrochloric acid, two is sulfuric acid, and three is a nitric acid. Now, when these acids are diluted, meaning when they're put into water, what happens? They ionize. So they split into its active components. And what are the active components that you notice? In all the given three cases, one of the active component is the hydrogen ion, which is H+. So this is an active component that is responsible for a given substance to be an acid. On the other hand, you have the other accompanying ions such as Cl- for HCl, HSO4- for H2SO4, and NO3- for HNO3. These are accompanying ions for a given acid. Okay. Again, let me repeat one more time. What makes an acid be an acid are due to the H+ ions. And these H+ ions are called hydrogen ions. On the other hand, what are the commonly used base? So now that we have discussed commonly used acids, let's look into commonly used base. So what are they? You've got sodium hydroxide, also NaOH, potassium hydroxide, KOH, and calcium hydroxide, CaOH twice. So what makes a base more corrosive, or what makes a base base? So what you notice here, as you dilute calcium as well, it becomes +2. So let us now move into the first type of reaction, which is reaction of a metal with acids and bases. So one such reaction is a zinc metal reacting with sulfuric acid. Zinc reacts with sulfuric acid, giving you zinc sulfate plus hydrogen gas. Can you identify what type of reaction this is? So there were different types of reaction that we have discussed in the previous chapter in chemical reactions and chemical equations. So can you identify which category does this fall under? Put your answers in the comments. For those who answer this question, again, I'll award you 5 more points. So go ahead, answer what category or what type of reaction does this fall under. 5 points, those who answer first. Let me see. Okay. All right. Some of you are like, no, sir, come on. Why don't you reveal the answer? Okay, I'll reveal the answer for now. Okay. So the type of reaction, what you notice here, so let me first describe what is happening, then reveal the type of reaction. So zinc here is displacing H2. So there's a displacement reaction, but there are two kinds of displacement reaction, which is single and the double displacement. So which is it? So here we see only one element displacing a H2. So this falls under category of single displacement reaction. All right. So this is an example of a single displacement reaction. Now what I want you to particularly notice for this given case is what happens when a metal reacts with an acid. So when a metal reacts with an acid, a salt, which is zinc sulfate in this case, plus a hydrogen gas is formed. Let us look into another example, but this time we will use a base. So here we have metal, which is zinc, reacting with a base NaOH, also called sodium hydroxide, to give you a salt, which is sodium zincate plus a hydrogen gas. So in both the cases, when a metal reacts with acid or a base, you see that the product formed is always a salt and a hydrogen gas that is evolved. So let us look into a picture, an example of a picture here where you have magnesium metal that is immersed into a hydrochloric acid. Notice how it readily reacts with hydrochloric acid, evolving gas. So the bubble is an indication that there's a gas that is evolved. So this gas that is evolved, which gas is it? Hydrogen gas, like we discussed previously. So let us try to write a chemical equation for this. So first you have Mg, which is magnesium, plus HCl. Let me rewrite that HCl once again, make it more visible. HCl gives, so what must you get first? A salt. So which is the salt formed? MgCl2 plus what else? The bubbles that are formed, what bubbles are they? What gas is evolved? Hydrogen gas, H2. Is this given chemical equation balanced? Check. Check. Reply. Comment the answers. Okay, those who answered this one, again, I award you 5 more points. By end of the session, those with the highest points will have a reward. Go ahead. Is the given chemical equation balanced? Yes or no? Anybody? Nobody. It's very common for a student to stay quiet even in classroom, isn't it? All very hesitant, like, sir, we don't answer because we don't want to get into trouble. Let me assure you, there's no way you can get into trouble on an online platform. So feel free to answer questions, wrong or right, doesn't matter. It's a learning trend, so please comment, answer the questions, and don't worry about the mistakes. Okay, so Mg plus HCl giving MgCl2 plus H2. Is the given chemical equation balanced? The answer is no. Why isn't it balanced? Here you notice you have 2 atoms of hydrogen, 2 atoms of chlorine, but here on the left hand side you see only 1 atom of hydrogen and 1 atom of chlorine. Therefore, what must we do? Increase this by 2 HCl. Now you have 2 hydrogen atoms, 2 chlorine atoms. Therefore, the given chemical equation is now balanced. All right. Now you may ask the question, how do I know that the given gas liberated in this case is a hydrogen gas? Do I have a test to conduct if this gas evolved as a hydrogen? The answer is yes, there is a test. Now hydrogen gas is flammable. It catches fire. So what you could do is, the same test tube in which you've conducted, you bring a flint close to the test tube and notice that it immediately catches fire. And once it catches fire, it ends up with a pop sound. Okay? So this pop sound with the fire indicates that there is hydrogen gas present in the given test tube due to the following reaction. All right? So I hope I've made this clear. Any doubts, any questions, put them in the comments and I shall answer them. Moving on to the next one is a reaction of metal carbonates and metal hydrogen carbonates with acids. So let us look into one such metal carbonate with an acid. So here we have a metal carbonate, which is sodium carbonate, plus an acid HCl giving NaCl, H2O and CO2. Okay, so not an issue here. Let us look into another equation where you have metal hydrogen carbonate. Here's an example of a metal hydrogen carbonate, which is sodium bicarbonate, also called as your baking soda, which you use it as your preparation for dosa, idlis, or it could be any of the other food that you use, baking pakodas, right? So a metal hydrogen carbonate plus a HCl giving sodium chloride H2O CO2. There's something common that you find here is when a metal carbonate or metal hydrogen carbonate reacts with acid, it gives you a salt, water plus carbon dioxide. So a metal carbonate and metal hydrogen carbonate plus an acid gives you always a salt, water and carbon dioxide. There's one thing that you will notice, something is missing here. And what is missing is the reaction of a metal carbonate and metal hydrogen carbonate with the base. Why doesn't it occur? Now the given reaction does not occur because metal carbonates and metal hydrogen carbonates are already weak bases. So a metal carbonate and a metal hydrogen carbonates are weak Yes, welcome back students. So like we were discussing, metal carbonates and metal hydrogen carbonates do not react with base because they are already weak base. Okay. So now here's one application of a carbonates reacting with the base. So it is used in geology to identify if a given rock sample contains carbonates, a metal carbonates. So here you see the bubbling that occurs. Yes, this is a carbon dioxide released, and the liquid that he pours on is nothing but the acid. Okay. So it's a very common test for rock samples to see if the given content is a metal carbonate or a hydrogen carbonate. All right. Test for CO2. Now that we have CO2 that is present, that is liberated for a metal carbonate, how do you test for it? Now, one test that you can conduct is taking the CO lime water, passing the carbon dioxide into the lime water, which gives you calcium carbonate plus H2O. So let me show you this by a picture. The transparent one is what is called as a lime water. Okay. Now once you pass carbon dioxide into this, what happens is that you get calcium carbonate. The white precipitate is what you see is a calcium carbonate, and the remaining is what you have as water. Now what happens if you pass excess carbon dioxide? Well, that's a question. Now, when you pass excess carbon dioxide, so you already have calcium carbonate plus H2O which is formed, and you pass excess carbon dioxide. And what is formed is calcium hydrogen carbonate. This is a soluble substance in water. Okay. So eventually you will see that the following will vanish. All right. So let's move on to the next one, which is called a neutralization reaction. Neutralizing meaning equalizing. Okay. So what do you mean by equalizing? Let's look into one such reaction where things get equalized. So one such reaction is when sodium hydroxide reacts with hydrogen chloride, giving you NaCl, which is a salt, plus H2O. Base and an acid gives salt and water. So it should be the other way around. Base plus an acid gives salt plus water. So let's look into the picture here. So in the following picture, you will notice the scientist here is using the indicator. This shows that the given solution is acidic, here that the given solution is basic. So you will see that this is HCl, which is an acid, and an NaOH. Notice what happens when he mixes two together. The color becomes transparent, showing you for a given reaction where you have acid and a base, it turns out to be a neutralization reaction where you have salt and water that is created. Again, one more time, have a look at the animation. So the universal indicator is more like those that we discussed as in the various types of indicators. So one of them being the universal indicator. All right. So very nice, lovely, right? Okay, so here we see there's another such reaction, a neutralization reaction that we just discussed. Metal carbonate and metal hydrogen carbonate reacting with acid, giving you salt, carbon dioxide and water. Finally, moving on to something that we're more familiar with is rainwater. Is a rainwater an acid or a base? Difficult to answer at this point, isn't it? But here's a reaction. When carbon dioxide dissolves in a rainwater, it gives you a carbonic acid. So here you see that rainwater is a little bit acidic, where you have a carbonic acid that is formed. The reason why it is acidic, because the active component here is the H plus ion, right? So what is a carbonic acid? Am I familiar? Have I come across this? And the answer is yes, you have come across carbonic acid. It is used in sodas. As you see, the fizz, the bubble that is formed, is due to the presence of carbonic acid, which in turn releases carbon dioxide. So this is a very common type of an acid that you have come across. Now what happens when a carbonic acid reacts or falls, or this rainwater, which is actually carbonic acid, falls on buildings? So let us look at statues and buildings. So here's a picture of one statue where it has been corroded due to the rainwater, which is slightly acidic. You don't still trust me? Here's another picture of a Taj Mahal then and now. Yes, the difference in the picture, you see, in the first picture it is completely white marbles. In the next picture it has been corroded, changed its color, and this is due to carbonic acid. Okay? All right. Moving on. One such reaction, metal oxide plus acid giving salt plus water. Metal oxide example is sodium oxide plus an acid which is HCl giving sodium chloride plus H2O. Now what I want you to observe is, in the previous case we discussed, when a base reacts with an acid, it gives you salt plus water. Yes? Do I have a base here? Can you see the base here? Is base present in any of the following cases? No. But you do have an acid. But the reaction, what it turns out, is the same as salt and water. So here we see that sodium oxide is behaving as a base. Therefore, metal oxides are basic in nature. Okay? Similarly, when I take a non-metallic oxide plus a base, gives salt and water. Let's look at an example. Non-metallic oxide such as CO2 plus calcium hydroxide giving calcium carbonate plus water. Even in this following case, it follows the same rule, where you have acid plus base gives salt plus water. Right? But do you observe an acid present? Is there an acid present in this following reaction? No. But there is a base present. Which is it? Calcium hydroxide. So there's a base present but no acid. But the behavior of CO2 is that of an acid. Therefore, non-metallic oxides are acidic in nature. Okay? Any questions? You can put them in the comments. I hope I've made this clear and easy for you. Now let us look into these questions. These questions are also from your NCERT textbook. So the first question is, why should curd and sour substances not be kept in brass and copper vessels? Brass and copper vessel, meaning metals. Okay, so these are metals usually. First of all, curd is acidic in nature due to the presence of lactic acid. Now in the discussion, what did we do? When a metal reacts with an acid, what do you get? Can you recollect? When a metal reacts with an acid, what do you get? A salt plus hydrogen gas. Therefore, The curd is not placed in a brass or a copper vessel is because curd reacts with brass and copper vessels to give you salts, copper salts or salts of brass, and plus a little bit of hydrogen gas that is evolved. Question number 2. Which gas is usually liberated when an acid reacts with a metal? Acid reacts with a metal. So what gas is liberated? Hydrogen gas, all right? The first part of the answer is hydrogen gas is liberated. Illustrate with an example how will you test for the presence of this gas. How will you test? First we will try to illustrate with an example. We will give an example, and the example we will choose is the same that we discussed, zinc plus HCl giving zinc chloride ZnCl2 plus H2 hydrogen gas. How will you test for the presence of this gas? Is by lighting it. So once you bring a flint close to this hydrogen gas, it immediately catches fire and results in a pop sound. Okay. The third question is here. Metal compound A reacts with dilute HCl to produce effervescence. The gas evolved extinguish a burning candle. Write a balanced chemical equation for the following reaction. One of the compounds formed is calcium chloride. So let's take what are the hints here. Okay, let's mark the hint. First you have a compound A. Okay, you have a compound A which reacts with dilute hydrochloric acid. So let me write A plus HCl gives, to produce an effervescence. The gas effervescence is nothing but bubbles that are liberated which has gas in them, all right. The gas evolved, this important statement, gas evolved extinguishes a burning candle. What can extinguish a fire? One is water, yes, and the other is carbon dioxide. You can extinguish a fire by using carbon dioxide. So what if there is no carbon dioxide around? Limit the use of oxygen. So which means the amount of carbon dioxide increases due to the burning process, and therefore you put off a candle or a given flame. So in case of this, you have carbon dioxide formed as 1, all right. Write a balanced chemical equation for the following. So these are the hints that have been given to us, and one last is calcium chloride, okay, CaCl2. So now I need to identify what is A. Okay, can you do this? Let me present you the answer, but before then let me see if anyone can reply to this. Go ahead, try your best and identify what is this compound A. Okay. Let me go ahead and present the answer. So the given compound A cannot still be identified yet because hydrogen is not present on the other side. So we have to account for hydrogen. So this hydrogen is accompanied by H2O. Let me just write that. Now let's try to determine what is the compound A formed. Now the compound A is calcium carbonate. Why is it calcium carbonate? First of all, you see there's hydrogen H and H, chlorine and chlorine. Next, you have calcium, that's one of the substance, so obviously there has to be calcium on the left hand side. carbon dioxide plus an additional oxygen, CO2 plus O, giving you CO3. So which means together it should have been calcium carbonate. Therefore, the substance A is calcium carbonate. So this will be your answer. So I hope I've made the things clear and easy to you. So these are the concepts that we've discussed today. One quick recap that we discussed things such as when a metal reacts with acid and bases, metal carbonates and metal hydrogen carbonates reacting with acids only, not with bases, recollect that. And also what is a neutralization reaction and some of the impacts where this neutralization reaction are observed. And the discussion as a problem solving questions and also chemical reaction questions based on your textbook concepts and questions which is of your NCERT. So that's it for today. I will see you in the next session. In the next session, I will be discussing more about acids, bases and salt, how to determine the pH of a given acid and a base. So make sure that if you have enjoyed this class, then make sure that you give a thumbs up and like and subscribe. Share it with your friends as well. I will see you soon. Take care everyone. Bye.